homework help. So first we're going to define, then we're going to work a couple of these problems out. So let's go. First of all, concentration. Let me explain this real briefly with a picture. So say, for example, you have a glass and you're trying to make Kool-Aid, and let's make it strawberry Kool-Aid. First, you're going to put some water in here, right? You're going to put some water in here. And next, after that, you're going to put some Kool-Aid in here. Now, you start off and you put, so you have a packet of Kool-Aid. First, you put a half of this packet in. Boom. And a half of this packet is going to make it decently strawberry, right? So that is a little bit concentrated, or concentrated in small amounts. So you're like, man, I want that to be stronger. So you put the rest of the pack in, right? You put the rest of the pack in. And when you put the rest of the pack in, then that makes it exceptionally strong Kool-Aid, okay? So this is really concentrated right here. This is really concentrated. There's two words you need to know. And number one, this water is going to be what is called the solvent. And this Kool-Aid is what is going to be called the solute. Now, the solute is what dissolves, right? And the solvent is what does the dissolving. So a solute, this Kool-Aid, is what is going to dissolve inside of this water, okay? The solvent is what does the dissolving, and that is the water. And so concentration is literally solute plus solvent equals solution. So concentration is how much solute, how much solvent is going to equal that solution, and how concentrated, how powerful it's going to be, okay? So concentration, solute, what dissolves, and solvent, what does the dissolving. Now, dilute literally means to bring the concentration down. And so if we were going to bring the concentration down, we would simply add more water to this, right? And if you add more water, what's going to happen to the Kool-Aid? The solute and the solvent are going to be out of proportion, and that is going to be weaker Kool-Aid. And so a weaker solution. It's a weaker solution. Now, concentrated means that it's the same thing as concentration, but concentrated means that it has enough solute and solvent to be filled. Okay, and there's basically three types of concentration. There's saturated, unsaturated, and then super saturated. So saturated is a concentration that has the maximum amount of solute inside of the solvent. Unsaturated is where there is not the maximum amount of solute in the solvent. And then supersaturated is where there's more than the maximum. And I know that sounds weird, but if you actually heat this up and then stir it all up, then it becomes concentrated again, saturated. And if you, at that point, with heat, you add more of this Kool-Aid, then it becomes super saturated. Okay? Molarity is another basic equation, and let's write this out. Molarity, capital M, equals moles solute, and I'm going to write it out, but after this I'm not going to. Moles solute over liters of solution. And obviously, anytime you have something over something else, you're going to be dividing, okay? So let's do this. We're going to calculate the molarity, capital M, right? Capital M. So we're going to molarity equals moles solute over liters solution, okay? And so now we're just going to plug the numbers in. And it tells us what we have. Moles of a solution, if there are 1.5 moles of NaCl, so molarity equals 1.5 mole NaCl. And I always write everything out as far as like the numbers are concerned. In 2.3 liters of solution. And then remember, this is liters of solution, the whole solution. And a whole solution is solute and solvent together. So 2.3 liters of solution. Now all we do is we just go over to our calculator. I think it was 1.5. Let's see, 1.5 divided by 2.3. 1.5, oh goodness, 1.5 divided by 2.3, and that's going to equal 0.65. We're just going to round that. So this molarity is going to equal 6, that's 0.65, 0.65, 0.65 molarity of solution equals 1.5 mole NaCl over 2.3 liters of solution. So all we did was just plug the numbers in there and divided. Let's do another one. So how many moles of sucrose would be in 8.7 liters of a 1.1 molar solution of sucrose? Inside of this question, we've got a little bit different equation. And so I'm going to keep it in black here. So we do not know moles, okay? But we do know our liters and our molarity. So we're going to plug our numbers in. 1.1 molarity, capital M. Remember our equation, capital M, molarity equals moles solute over liters solution. Okay, so we've got that 1.1 equals, and we do not know our moles, so we're going to put a question mark there. And then we're going to put our 8.7 liters of solution. And so, this whole deal as far as like, if you don't have something up here, then you're going to cross multiply. So we've got 1.1 divided by 8.7. So let's look at this. 1.1 or multiplied by 8.7, and that's going to give us 9.57. So that's going to equal 9.57 moles of C12H22O11. So that's pretty simple stuff.